In this video, we're going to review the graphs of the 6 trig functions. Let's take a look at y equals sine x first. And below that, you see I have set up for you a t-table on the left, which is a very common way to graph a function. And then on the right-hand side is the graph we're going to use. And I want to point out that on the x-axis, that those just aren't our regular numbers. Let's take a look at that real quick. We have the origin, of course. Then we have pi over 2, pi, 3 pi over 2, and 2 pi, etc. in both directions. So now, because we're dealing with trig functions, our x-axis is actually angle measures. And they're not just any angle measures. If you notice, they are the quadrant angles. So these green points that I've circled for you, that's what we're going to use to find the graph for this. Those are going to be our x values. So we're going to have an x column and a y column, like any old t-table. We're going to plug in values for x, and we're going to get what the y values are. And so the y values look the same, 1, 2, 3, 4, etc. Now, where am I going to get these values from? Well, we talked about the unit circle in one of the earlier videos and how to find the trig function values for those quadrant angles. So if you need to refer back to your unit circle to get these answers, that's where I'm getting them from. So let's take a look with sine x, and we're going to start with 0. We're going to let x equal 0 degrees or 0 radians. Or notice our x-axis is actually in radians. And we plug it in for x right there. So we're actually finding the sine of 0. And the sine of 0 is just 0. So that's our first ordered pair, 0, 0. Then we're going to move to the right of that on the x-axis, and we're going to let x equal pi over 2. And we're going to plug that in, so y is equal to the sine of pi over 2. And we know the sine of pi over 2 is 1. So our next ordered pair is just pi over 2, 1. Moving down the line, our next x value is going to be pi. We plug that in. Y is equal to the sine of pi. And the sine of pi is 0. So that's going to be the ordered pair pi, 0. So we're back on the x-axis. Then we're going to plug in 3 pi over 2. Y is equal to the sine of 3 pi over 2. And the sine of 3 pi over 2 is negative 1. So that next ordered pair is 3 pi over 2, negative 1. So that's 1 below the x-axis. And then we're going to finish things up with 2 pi, which just makes this full circle. And the sine of 2 pi is 0. So we're back on the x-axis. So these are our 5 points that we need to know. Let's go ahead and connect them. Here's our sine wave. And we can keep on plugging in angle values, or we can just pick up on this pattern. You probably see a pattern over here in the table, 0, 1, 0, negative 1, 0. But you also see a pattern in the graph. We start at the origin, 1 above the x-axis, 1 below the x-axis, x-axis. Then we'll go 1 above the x-axis, x-axis. So we can finish drawing the graph this way. We can also use that pattern to finish graphing it to the left of the origin. So origin, down 1, x-axis, up 1, x-axis. So there's certainly a pattern there, and you can use that to your advantage. Now, the blue part is one complete cycle. And one cycle meant we went full circle from 0 and to 360. And so what we want to find now is something called the period, which is the distance it takes to make that one full cycle, that up and down movement. And then it keeps repeating up and down and up and down. And it's a wave, the sine wave. That's why we call it the sine wave. And so the period for the sine wave is 2 pi, because it takes from 0 to 2 pi to make one full cycle. And then the pattern repeats. The second thing we want to talk about is the amplitude. And the amplitude is the height here from the x-axis to the maximum. That would be a maximum. That would be the peaks are the maximums. Or it's also the distance from the x-axis to these minimum points. Peaks and valleys maybe, maxes and mins. Regardless, it only goes 1 unit up or 1 unit down. And because it's a distance, it's positive, so the amplitude is 1. Okay, so the amplitude of the sine wave is 1. So we're going to look at the graphs for the other 5 trig functions as well as their period and their amplitude. We're going to approach these the same way using this t-table idea. So let's take a look at y equals cosine x. Well, we need an x column and a y column. And we're going to go and start with 0, just like we did with sine. We're going to plug it in. Y is equal to the cosine of 0. And the cosine of 0 is just 1. So there's our first point at 0, 1. Then we're going to go to pi over 2. Plug that in. Y is equal to the cosine of pi over 2. And the cosine of pi over 2 is 0. So now we're sitting on the x-axis again. And we'll plug in pi. So y is equal to the cosine of pi. And the cosine of pi is negative 1. So now we're 1 below the x-axis. Then we'll plug in 3 pi over 2. And we'll plug that in. Y equals the cosine of 3 pi over 2, which is 0. And plot that. That's on the x-axis. And going full circle to 2 pi, y is equal to the cosine of 2 pi, which is back to 1. So this is one full cycle. These 5 points, it's much like sine, except it starts one above the x-axis. The sine wave starts at the origin. So here we see we went one above x-axis, one below x-axis, one above. Let's go x-axis, one below. And we can go the other direction. One above x-axis, one below x-axis, one above. So it's just oscillating back and forth like that. And it's another wave, very much so similar to what the sine wave looks like. So that blue portion, I left that blue for a reason. That's one cycle, so it has the same period. The period is 2 pi. That's the distance it takes to complete one cycle. The amplitude for cosine, it is also 1 because the highest point is 1 and the lowest point is 1, and that's the distance from the x-axis to the maximum point or the distance from the x-axis to the minimum point. It's important to remember that amplitude is always positive. Now, tangent's going to be a little bit different, just in the sense that it's not continuous. We can say that sine and cosine are continuous because we could actually draw that up and down movement without ever picking up our pencil. And if you recall from the unit circle, we have some parts on the tangent function that give us undefined answers. So we're going to see how to deal with that. So we need an x column and we need a y column. We're going to start with 0 and we're going to plug it in for x. Y is equal to the tangent of 0 and the tangent of 0 is 0. So we're going to put a point right there. Then we're going to move along just as we've done in the others. Pi over 2. Y is equal to the tangent of pi over 2. And the tangent of pi over 2 is actually undefined. So I'm just going to let that be a u. Well, undefined means there's no piece of the graph there. So what that means for our picture is we're going to have an asymptote. Now we're going to draw this as a vertical dotted line because an asymptote is really an imaginary line. So the way we draw the imaginary lines in math would just be represented by a dotted dashed line. The graph is actually never going to touch that line. It's never going to cross it. It's going to get very, very, very close to it though. All right, moving right along, we plugged in pi over 2. It's time to plug in pi. Y is equal to the tangent of pi, and the tangent of pi is 0. So we got a point at 0. And then we're going to plug in 3 pi over 2. So y is equal to the tangent of 3 pi over 2, and that's another undefined piece. So when we have an undefined piece, we're going to draw another asymptote. So you're probably already picking up on the pattern. But let's finish it by plugging in 2 pi. So y is equal to the tangent of 2 pi, which is, you guessed it, 0. So where the asymptotes are going to be, we can fill up this entire graph I say the asymptotes are on the halves because it's at pi over 2, 3 pi over 2. Then we'd have another one at 5 pi over 2. And over on this side, negative pi over 2 and negative 3 pi over 2. And then we have all these zeros. So we have a 0 at negative pi, a 0 at negative 2 pi, and a 0 over here at 3 pi. And then the graph of this actually takes this S shape. Okay, you really just need to know this sketch right here. It gets really close to the x-axis. Really close to the asymptotes. Crosses the x-axis, but the sides get real close to that asymptote, never crossing it, never touching it. Now, what's happening is how I know that those points are there and the curves go that way is let's just focus in right here. If this is 0 and that's pi over 2, which is 90, then right in the middle is pi over 4, or 45 degrees. And we know the tangent of pi over 4 is 1. So that's where that point's coming in, giving it that curving up shape. Likewise, negative 45 would be in between negative pi over 2. And the tangent of negative 45 would be negative 1, which makes it turn that way. Again, this is just a sketch, so that's the idea of where this is coming from. Now, let's talk period. The period for tangent is not 2 pi, it's only pi, because one of these little S-shape graphs, that's one cycle. And it only takes 1 pi unit to make one cycle, because that's a half a pi and that's a half a pi. Half and a half makes a whole pi. So our period is pi. And with amplitude, remember we said amplitude is dealing with the maxes and mins, and I don't have any maximums or minimums here because I have these arrows. It's going up forever and ever and down forever and ever. So the amplitude, we just don't have one. There's no amplitude. All right, since that was tangent, we're going to do cotangent next because they're very much so similar. So let's go to cotangent. All right, setting up our t-table, you guys get the idea now. X and y, we're going to start with 0. Y is equal to the cotangent of 0, and the cotangent of 0 is undefined. So we start straight away with an asymptote on the y-axis. So let's go ahead and put that. Moving along, we're going to plug in x is pi over 2. So y is equal to the cotangent of pi over 2, and the cotangent of pi over 2 is 0. So we can put a 0 there. Moving along, we're going to let x equal pi, and y is equal to the cotangent of pi and the cotangent of pi, and we're back to undefined. So that means we have another, you guessed it, asymptote. And moving along, we got 3 pi over 2. Plugging that in, y is equal to the cotangent of 3 pi over 2. And the cotangent of 3 pi over 2 is 0. Right there. And lastly, we're going to plug in 2 pi. Y is equal to the cotangent of 2 pi. And the cotangent of 2 pi is, you guessed it, back to undefined piece. So we need another asymptote. And you see the pattern, so you could keep plugging in angles, but it's just going to keep going back and forth. So there's a point. This would be a point, skip one point. And then this time, the asymptotes for cotangent are on the integers. The asymptotes for tangent were on the halves, pi over 2, 3 pi over 2, 5 pi over 2. And now they're on 0, pi, 2 pi, 3 pi, negative pi, negative 2 pi. And cotangent, just drawing the sketch here, is much like tangent, except the little curves go the other direction. So at first glance, they almost look the same, but if you actually put the two next to each other, you will quickly see the differences. Quickly see the differences. Now the period is the same. The period is just pi. and the amplitude is the same too, there is no amplitude because there is no max and no min. All right, wrapping things up with secant and cosecant. Let's go ahead and look at cosecant first. And when we graph cosecant, we're actually not going to use the t-table here because cosecant is based off of sine. So what we're really going to graph, we're going to start with y is equal to sine because sine and cosecant are reciprocals of each other. So I'm going to very lightly, in a light gray, graph sine. Remember, it starts at 0, 0, goes up 1, hits the x-axis, down 1, x-axis, up 1, x-axis. And I'm actually going to draw it using a dotted line because it's not going to be my main picture. Now, wherever your sine wave is crossing the x-axis, they're going to be asymptotes. So I have an asymptote when x is equal to 0. I have an asymptote at x is equal to pi, and x is equal to 2 pi. We have asymptotes at all the x-intercepts. Now let me explain why. That's pretty important, right? Well, what this graph says is, like, let's just say pi. If x is pi, then y is equal to the sine of pi, which is 0. I'll make that pi. All right, well, if the sine of pi is 0, then the cosecant of pi is the reciprocal of 0. Well, that 0 is over 1 technically, so if you take the reciprocal of that, you flip it 1 over 0, and that's undefined. So when when sine has a value of 0, cosecant has an undefined value. Okay, so that's where the asymptotes go. And then on these peaks and valleys, these maximums and minimums, you just make this little parabolic shape, ups and downs. This graph can get a little bit messy. The first three, of course, are the most common, but we definitely want to review all of them. Now we also need to talk about period. Because this is based off of the sine wave, the period is still 2 pi. But to re-emphasize that, one of these up and one down makes one cycle. So you can see that distance is 0 to 2 pi, so the distance is 2 pi. The amplitude, however, is not the same as sine because amplitude deals with maxes and mins. There is no amplitude because these go straight all the way up and all the way down. So we're going to finish things up with secant, and we're going to base secant off, you guessed it, the cosine graph. So let's go ahead and graph cosine. We're really just graphing cosine. So let's use a light gray, and cosine starts at 1, hits the x-axis, down 1, x-axis, up 1, x-axis, down 1. Other side, x-axis, down 1, x-axis, up 1. I'm only going to use a little dashed line because this is not my main picture. If you're using a pencil, you don't have to make it dashed, but you could just make it really, really light. You don't want anybody to think that's your answer. All right, for the same reason, as cosecant and sine, where this graph crosses the x-axis, we have asymptotes. So asymptote here and an asymptote here. We say that we have asymptotes at all the x-intercepts. So when cosine is crossing the x-axis, we have an asymptote. And we have that same shape. This side has ups and a parabolic shape down. And up and down. And up and down. And much so like cosecant, the period is still 2 pi, and the amplitude is none.